and the dynamic duo of solar energy. So this is Ben. I am Assistant Professor in the Department of Triple and in BSN's College of Engineering and Technology. So the solar energy that is coming from the primary source of the earth, which is the sun, has two dynamic duo. The first part is the PV and the second is thermal. So PV, in this we can extract the power by means of converting the photon of the sun that is coming from the sun to the electricity, and in case of thermal we are extracting the energy by means of radiation that is coming from the sun. Both are different topics, but they are related with the advantages of clean and sustainable source of energy. So initially in part 1 we can see about the solar photovoltaic energy. So the definition of solar photovoltaic is simply explained as it is a technology which is meant to convert the sunlight directly into the electricity using semiconductor materials. So the photons which is present in the sunlight is directly converted into electricity by means of semiconductor materials. There are different semiconductor materials that are available in the earth. So in this we are using silicon, which is adaptable for most of the condition for energy extraction. So silicon is one of the major player of this solar photovoltaic, and the mechanism used for this is the solar photovoltaic effect, in which the photons coming from the sun is converted to electricity. So they are commonly seen in rooftop systems and solar farms. Mainly the photonic energy from the sun is converted to the electricity by means of this photovoltaic effect. So the principle of PV technology, as seen in the previous slide, it is based on the photovoltaic effect. The light photons hit the semiconductor, especially silicon. So the electrons present in the semiconductor are excited by this photonic energy. That is an energy transfer, and this makes an electron to flow from one potential to, that is the higher potential, to lower potential through the load. If the potential is very much high, the amount of electron flow is very high, thereby the current also. So the key materials used for this is especially silicon, okay, because it is one of the very important semiconductor which has a good property to behave like a semiconductor in this present conditions of the atmospheric earth. And here there are two types, which is monocrystalline and polycrystalline. So p-type cells uses silicon doped with boron, in which there is one electron shortage, because boron is a trivalent compound, and when you compare connect or bond this boron with silicon, which is having 4 electrons in the outermost shell, there is shortage of 1 electrons. So next, in case of n-type cells, the silicon is doped or integrated with phosphorus, which has excess electrons, which is phosphorus is a pentavalent compound, so in which the 5 electron is orbiting over the outermost shell of the atom, so it has 1 electron excess when it is doped with the silicon. So working mechanism of PV cells. So this is one of the basic working mechanism of PV cells. Initially there is photon absorption. So the photon that is coming from the sun is absorbed by the silicon material, so which transfers their energy to the electrons. The electrons, which has some amount of energy, so that is being transferred to the electrons of the silicon. So this energy transfers make the electron to be excited. In the second point, so we see that electron shares the energy or gains the energy from the photons, and this gain causes the electron to break free from their atomic bond. So this transfer of energy causes the electron to escape from the outermost orbit of the silicon compound, and thereby one free electron is created, and more free electrons are created from alternative silicon cells, and this makes the empty spaces. The empty spaces are the holes. So there is a potential of a bunch of electrons in one side and bunch of holes that is created on the other side. So this makes the free electrons to be transferred from one part to the other part. So the free electrons are then attracted to the positive side of the cell, and while the holes move to the negative side, and it is simply only thing, the electron is being attracted to the positive side, and there is hole which is asking for the escaped electron to retrieve its position. And in case of circuit connection, the electron flow through an electrical circuit. So the electron that is gathered toward one side, that is the positive side, so moves to the next side by means of the circuit connection, and this circuit connection, when it receives an electricity through a load, the load is being powered, or this energy can be stored in the batteries. So what is the amount of voltage and current to be controlled in the sense? So if you want higher amount of voltage, we can connect it seriously, and if you want if you require the higher amount of current, we can connect it parallelly to achieve the maximum value of voltage and current. So the energy extraction is very much simpler by means of PV cells. The output energy is the direct current energy that is coming out of this, and the voltage and current is being controlled by series and parallel connections. So this is the diagrammatic view of working mechanism of PV cells. So initially in this area, the photon is being transferred from the sun and it is reaching the solar cell. So this photon absorbed in the depletion zone, and this photon triggers the electron present in this region, and thereby an electron hole creation happens, and this electron hole creation, this electron tries to flow through the load and then it reaches the hole part, and this is the basic mechanism of working of the PV cells. So components, what are the basic components of a PV systems? So in the previous slide we just saw the mechanism of PV system, and in this we just see the components of the PV system. So basically it consists of solar panels, and solar panel is explained as it is a module of solar cells, and it consists of inverter which is used to convert DC to AC, because all our home appliances are AC. So in this regard, we can't able to connect the DC directly to the load. So inverter is a prime element to convert DC to AC. And mounting structures are basically GI pipes which is used to mount the solar panels or modules one to one. And next, battery, which is optional, and battery is an essential component which is used to storage the DC power that is being extracted from the solar system. And the form of energy is chemical energy, and this chemical energy is converted to the electrical energy by means of the inverter, and this inversion is being controlled with the charge controller, because in order to regulate the voltage, we are connecting the charge controller with this. And what are the advantages of PV system in the sense? They are renewable and sustainable, because in the present day world, the sustainable is one of the important terms to be discussed, because what we are living for the future becomes a question. So if the pollution and the same phenomenon of energy extraction increases, there is a question mark for the future energy needs. Also, there is some critical things happening in the health of the human being, and there is a huge destruction of ecosystem, biodiversity changes and climatic changes are experienced. So in order to maintain all the things and in order to have a sustainable solution, PV becomes one of the better and superficial solution for all the problems, and which is also renewable, because sun gives unlimited energy which can be extracted anywhere. And next, there is no emissions during operations. So it is one of the stable system. There is no rotating bar, there is no emissions, there is no fuel input. Okay, so unless otherwise during the production, other things are it is completely termed as emissionless operation, and without any emissions or without creating any pollutions, it is one of the silent energy producer, and it is very highly sustainable. Also, the maintenance is very much low in case of the PV systems. So next, decentralized power generation means in this regard. So the solar panel can be launched anywhere unless if you have any one of the system, it can be launched anywhere. So in case of generators, in case of nuclear reactors, in case of any other production methods, either by fossil fuels or by hydroelectric plant, it can be centralized. It can't be decentralized. But the solar it is decentralized by placing it in rooftops, by placing it in farmlands. So anywhere we can use it and we can decentralize it, and anywhere we can access it, as it was one of the universal placement as a placement that has the universal placement throughout the farms or houses. Anywhere we can place it and we can extract the energy, and it is highly scalable, so we can use it in a small scale or we can use in the high utility scales also. And coming to the disadvantages of PV system, the initial installation cost is very much high. So the cost of production, the cost of extraction of silicon, the cost of manufacturing, and the cost of transportation to the site is very much high. So, and the cost of installation of solar and the labor cost also very high. So it has higher installation cost. It is considered one of the disadvantage of the PV system. And in case of output, during the cloudy day or during the rainy days, the photon emission from the sun is very much low. So this condition provides the output to be uncertain. That is, it produces intermittent output. So it always depends upon the daylight. So if there is no daylight, the output becomes zero. And during day conditions, if there is cloud and if there is any rainy seasons, so the output becomes intermittent and it is highly non-advisable in case of high voltage systems. So, and next, it requires large area for large scale setup. So if you want the area coverage by the solar PV system is very much high. So the area considered for energy extraction will be very high in case of PV systems. And the battery storage also, if you want to install a battery during the extraction during night, so it also being a reasonable cost to be added upon the installation cost of the PV systems. So battery storage increases cost and also increases maintenance and also increases many technical issues associated with it. So this becomes one of the disadvantage of the PV systems. In last, it is the efficiency limited by technology. However, it is advantageable, however it is clean, however it is very pure, causing less pollution, causing very less carbon footprints. The efficiency associated with the PV systems is very much low. So the nominal efficiency that is taken out is around 10% to 15% in around 2000 cell in amorphous solid silicon cells. Nowadays, as crystalline is being used, now the energy efficiency is not doubled, it is just increased to 15 to 22%, which is seen as one of the less efficiency by a generating unit for producing power. So diesel engine power plant or any thermal power plant produces nearly 40% of output and output efficiency. And comparing to the thermal and nuclear power plant, it is very much low, and this becomes one of the disadvantage of PV system. And some of the interesting facts about PV systems are the question regarding the PV cell efficiency, as discussed in the previous slide. It is around 15 to 22%. The initial solar cell was invented in 1954 by a group of scientists in Bell's lab, and largest solar PV farm in India is the Bagla Solar Park, India. And while comparing to the global electricity, PV contributes nearly 4% of the total power supply for the demand by them. Okay, what are the next slide is what are the challenges facing PV? So PV faces lot of challenges. The initial challenge is if you invest rupees 100, the output will be only for rupees 22. So efficiency is around 22%, which becomes one of the challenge, and lot of technologies are being raised which deals with this efficiency improvement. So this technology can be discussed later, and this is one of the challenge faced by the scientists and engineers. And next is the weather and location dependency. So if there is poor weather and it is placed in a less optimal siting area, the output is a highly uncertain thing, and in order to reduce this you have to make lot of investigations and scrutinization regarding the weather and the location, and which is become a challenging factor of this PV. And next, waste management. So a lifetime of the PV is around 25 years for a maximum limit. Okay, after this it has to be disposed. So this disposal requires a huge amount of area, which again questions the purity of the land, biodiversity, and question the optimality of the ecosystem. So all the things again becomes a challenges for the scientists to deal with. And next, the integrated with the existing grid, because it produces DC power, it is connected to the inverter, and it has to synchronize with the AC power of 50 Hz frequency. Again, this becomes one of the toughest challenge that is the PV facing. And next, coming to the solutions and innovations. In the previous slide, we seen about the various challenges regarding PV, and what are the solutions that scientists just now received or reached is perovskite solar cells, which has a higher efficiency and lower cost. So perovskite, in the sense, it is a specific crystal structure. It is a specific crystal structures that we cannot able to see. So it is covered by ABX3. ABX is cation and X is anion free structures, and it has the titanium oxide and glass substrates and deal with different types. It can transmit energy with a higher efficiency with low cost. So both economically and technically, perovskite solar cells are being replacing the normal silicon solar cells. So it becomes one of the innovative technology. And next, coming to the next technology, it is bifacial modules. So bifacial modules, in the sense, in the next slide we can see. So this is bifacial solar panels. So it can absorb sunlight from both the sides. So from this side, the direct sunlight is coming through the front side, and the diffuse radiation, that is the radiation that is coming after hitting the clouds. So the diffuse radiation comes to the back part of this solar PV cells. So it adds the advantage of both direct sunlight energy extraction and also the diffuse sunlight energy extraction. And it absorbs, and bifacial models, it absorbs light from both sides, thereby efficiency also increase in terms of this technology. And net metering and feed-in traffic, this is the one of the demand side management technique. So in which customer becomes a major part, in which the decentralized power generated by the customer is being bought by the electricity boards or the energy markets. So and then it is fed to the grid and at certain transaction rate. So if there is high demand in the grid, the electricity board will purchase the power from the customer and then it distributes to the grid. And during the low cost conditions of power in grid, we can attain the power and we can use it. And feed-in tariffs accordingly, which is it can be decided by the customer at what time, at what rate we can receive the power from the grid and sell the power to the grid. And floating solar farms, so the main aim of this floating solar farms is to save the land and reduce the evaporation of the water. So it has a dual advantages. So in this we can't use this land, so we can use the watery areas, so in order and make the solar cells to float. And this has the dual advantages of saving the land, especially agricultural land or any commercial land. So and thereby it has the other advantage of reducing the evaporation of water. So also it supports good biodiversity and good aqua-like structures. And coming to the second part, it is the solar thermal energy. So in this, the radiation, the heat from the sun is being trapped. In the PV technology, the photonic energy is being trapped and it is used to electricity production. Here the PV thermal absorbs the heat from the sun, that is heat in the form of radiation. So it captures sun's heat to produce thermal energy. So it can be used in different ways. Either it can be used as heat and it can be used for electricity generation. In terms of heat, we can use it for heating the water, heating a particular space, heating a particular medium. And in terms of electricity generation, the steam is produced by this heat and the process steam is being passed to the turbine for electricity generation. So majorly they are using this water heating and space heating as a better application of this solar thermal energy. And next, in case of collectors, PV collectors, so PV cells are present. In terms of thermal collectors, aluminum plates are present, especially aluminum, which is one of the high heat absorbing metal and which is used for the collection of the heat from the sun. So principle of solar thermal system. So this is based on solar heat absorption. Heat from the solar, that is the sun, is being absorbed and then it is used for the heat transfer, and it can be used, the heat is further used to transfer to the working fluid, and then it carries the heat for the human applications or any other industrial applications. So initially it has a black surfaces which has high radiation factor, so that it absorbs more radiation, and the heat transfer from this black surfaces is done through the working fluid. Either it might be air, it might be water, or it might be oil. So it carries the heat from this medium, any one of the fluid, and it can be used directly for any applications or directly for storage. So this is the basic schematic diagram for the principle which is explaining the solar thermal system. So initially the sun heat is trapped in the solar collector, and this fluid is being, cold fluid is being entering here, and this cold fluid is passing throughout this collector, and then it is converted to the hot fluid and it is transferred to the tank. So it can either be directly used by means of taps or by means of boiler, or we can use it by means of any storage unit also. So this boiler, when the output is coming out, it becomes cold and it is again fed to the solar collector by means of pump. So this is the next is the working mechanism of solar cells. So sunlight is being absorbed by the collector. The heat is transferred to the fluid by means of either water, oil, or any phase changing material, or any material that is having high heat absorption capacity. So and next the fluid is being circulated to the heat exchanger, where the heat is being exchanged, or it can be transferred to the thermal storage with any phase changing material or any rigid materials. So and next applications of this solar thermal is the domestic water heaters and industrial heat and power plants. So types of solar thermal collectors: flat plate collectors. For it is mainly used for residential water heating. So this is the schematic of flat plate collector. It has a absorber plate. So it has insulation tubes and flow tubes and header. Insulation placed over the bottom will avoid the heat to be transferred from the bottom layer of this aluminum sheet. The absorber plate is made of aluminum, which is one of the alloy of aluminium. And next there is flow tubes in which the cold water is being transferred, and in which the fluid that is used as a heat transfer fluid can be passed over this, and this header act as a grid for connecting all the plates, all the pipes, and then gives in the outlet. So this is mainly used for residential water heating. And next is the evacuated tube collector, which has higher efficiency and less heat loss, in which the cold water is given in, and the radiation from the sun is absorbed in this area, and slowly the cold fluid entering becomes heat. So after this U-turn it becomes extremely hot, and then it goes out. It has high absorption materials. This is the reason why this cold water becomes hot. And next is the parabolic troughs on dishes. So it is used in the solar power production, combined solar power production. So here, so this is the parabolic dish, or it can be said as parabolic troughs. So this looks like a receiver of a communication signal, and it has coating material of aluminum, and it is supported by the bars. So all the rays that is falling over the dish will be collected in the central focal point, and in this point that working fluid is being transferred, that is the heat transfer fluid is being transferred, and the power is hot water is being extracted. So this is the one-line schematic, that is it has a receiver, that is the in which all the that is all the rays coming in the dish is reflected and being collected to this portion. So, and here the working fluid is transferred, and this working fluid is further transferred for thermal storage or thermal working process. And next is the heliostats, in which the mirrors and mirrors are focusing the sunlight towards the tower receiver. So here there is a tower, here there is a receiver. All the things placed over here is the mirrors. They are reflective mirrors, and which receives the sun's energy, sun's radiation from this, and then it transfers to the common central tower receiver, where the working fluid is transferred. This is the basically used for CSP systems. So here nearly we can achieve around 250 to 500 degrees centigrade of heat. So this heat enough to have a good high pressure steam, and this steam can be used for producing electricity. So as a recap, so I am telling about the solar thermal collectors. So the flat plate collectors, it has a flat plate structure which has absorber plate, tubes, and which collects the energy, and this energy is being transferred to the working fluid and taken in the outlet. And next is the evacuated tube collectors, which is a U-type tube is there, in which the cold water is being given inside, and the solar radiation is being absorbed by the aluminum coating over the tube, and it is being transferred to the hot water. And parabolic troughs and dishes, and it has a focal point and a reflector. The radiation that is falling in the reflector is being absorbed in the focal point. And in the case of heliostats, it consists of mirrors, not special designed aluminum things. It is only the mirrors, and all the mirrors focus their direction in the form of to the central tower receiver, and the central tower receiver holds the working fluid, which transfers the cold water or the cold working fluid to the high temperature working fluids. And advantages of solar thermal is having higher efficiency compared in case of heating. So not similar to the PV, it has higher efficiency, and this technology is very much simple, as we do not require any complex technology for small scale application, because it requires only heat transfer pipe and aluminum sheets. And next is the low operating cost, and it is high. The operation cost of the solar thermal is entirely nil and there is less operating cost. So if you want a rapid heating, so then only we can need a pump. Otherwise, the solar thermal is extremely free, similar to solar PV, and good for off-grid heating applications. If you are going for any off-grid areas or remote areas, you can extract the solar thermal, and it is very easy and cheap way of extracting the sun's energy and utilizing. And next is the less expensive, and it is than PV for heat based uses. So if you installing PV and using for heating applications, it is one of the crime, technical crime. And if you are using directly a PV that is heat based output, it is very good. And disadvantages of solar thermal. So there is heat loss in storage and transmission. So however we speak about it has high efficiency. The heat can be transferred easily through the atmospheric area. So the transmission is very high, so the loss will be very high. And it also similar to PV, it also depends upon the weather and seasonal variations which will affect the outputs. And similar to solar PV, it also requires large space for the collectors, and it is difficult to convert electricity efficiently. However, in case of advantages, we see the efficiency is very much more, but in case of conversion of electricity, already the conversion is around 30 to 31%. Converting this 30 to 31% to electricity is again produces a less efficient system, and this becomes one of the disadvantages of solar thermal. And next, in the case of maintenance, this system has higher maintenance due to scaling and corroding issues, as the working fluid gains the moisture from the atmosphere, and it leads to higher maintenance, and thereby it consumes lot amount of cost. And coming to the challenges in solar thermal, so it has limited electricity generation compared to PV. So converting the radiation of sun to the heat energy it has a very less efficiency, around 30 to 33%. After converting this 30 to 33, then it has to convert to electricity. In the sense, the overall efficiency of the system becomes a very low thing, and this becomes one of the question raised by a lot of scientists, that why we need to convert these two ways of energy conversion for attaining electricity. So comparing to the solar PV direct electricity conversion, solar thermal electricity conversion is always having less efficiency and less power, and becomes a challenge in one of the energy conversion systems. And next, land requirement for CSP plants is very much high, and this reduction of land is can't be done, because if you increase the size of the heliostats or size of the heat absorption reflectory areas, so definitely we require higher, because there is a limit for energy extraction through the solar thermal. So land requirement for CSP is very much high. And next, in terms of scaling issues for urban settings, so scaling issues is one of the challenges, because there are different types of pH levels of water is being available at different urban areas. So scaling issues arises. So this becomes one of the challenges for solar thermal power plant. And complicated integration with HVAC. So here the heat transfer is completely not rapid, it is very slow. But in modern HVAC systems, the heat transfer either by means of cooling or heating is very much fast. So it is not adhesive with the modern HVAC systems, and these are the challenges that is faced by the scientists while dealing with the solar thermal systems. So modern solutions include, it has molten salt storage, so in which we can store up to 290 degrees centigrade to 565 degrees centigrade. So molten salts, or specifically the sodium or potassium nitrates, that can be used for this. So here it have high thermal stability and can store large amount of heat in relatively small volume. And hybrid PV thermal systems are being raised, and this becomes one of the solution. And integration with biomass and backup boilers, so and thermal batteries and phase change materials for storage are one of the important solutions for this solar thermal. And this is the schematic of the molten salt storage systems. So here the graph is started between temperature and energy content. As the temperature increases, the energy content increases, thereby molten salt will grow from solid state to liquid state. This is one of the technology by which we can store around 290 degrees centigrade to 5 degrees centigrade, 565 degrees centigrade with higher amount of energy storage content. Thank you.